Hey, Keyshawn here, and today I want to debut a series that I'm calling How Do You Know? Where I go through pieces of evidence that we have that make us think the dark matter is a thing. So I'm basing it loosely on this amazing article by my friend Ethan Siegel, which you should read when you're done watching this. But today we're going to talk about, I think, probably one of the most iconic forms of evidence, and that's galaxy rotation curves. Okay, so this is the Andromeda Galaxy, beautiful sort of grand design spiral, not unlike the Milky Way that we live in. And one thing about these types of galaxies is that the bulk of their mass is concentrated toward the center in a part that we call the bulge. And the way gravity works is there's kind of two ways you can make it weaker. You can turn down the mass that's involved, or you can take the two things gravitating and make them further apart. So what we should see if we look at the velocity, which is to say speed and rotational direction of stars in a galaxy like this, is as you move away from where all the mass is, there in the bulge in the center, you should see slowing down because the gravity should be less because you're getting farther away from where all the stuff is. So the force should go down and therefore the acceleration should go down. But notice I said we expect to see that. We should see that. In fact, that is not what we saw. So Vera Rubin and Kent Ford looked at the rotation of stars in the Andromeda Galaxy, and they published this paper. This is from 1970, so a while back, and this is a very famous plot, one of the most, honestly, famous plots in astronomy, probably. And as you can see on the x-axis there, they've got the radius out, so basically how far from the center of Andromeda they're looking. And then on the y-axis there, the vertical axis, they've got the rotational velocity, so how fast is the star going around. And I said you'd expect to see a drop-off in speed, but you don't. You see it staying pretty consistently high. So you see it increasing as you enclose more of that bulge, then a sharp drop-off as you get further away from where all the stuff is at. And then you see it kind of come back up and sustain, which implies that there's stuff, more stuff. And whatever the stuff is, it's not making light because it looks like nothing is there. But clearly, gravitationally speaking, something is there. So this is one of the kind of strongest pieces of evidence that we got for dark matter, which confirmed some theories that were already swirling and had been kind of swirling since the 1930s. So Vera Rubin and Kent Ford. Remember the names, and we'll go over a lot more pieces of evidence.